So we decided today we wouldn't follow the normal format because usually what we do, we stand up on our hind legs, we explain what Raspberry Pi is, who we are. I think you all know who we are, yeah? I'm Liz, I'm from the internet. This is Evan.
I'm also from the internet.
And you've already met Clive. So we thought that what we would do today, rather than giving a talk, would be to take questions from you guys, because I'm sure there are things that you would like us to cover that we don't normally talk about. So, over to you. Hands up.
So I'm going to start with one question from the internet.
The internet itself.
Okay, so the internet says, what are the next steps for the Raspberry Pi hardware? What are the next steps?
Okay. So we've mostly been busy on software this year. A lot of the work we do is software work. And the reason we focus on software is that software improvements benefit. We've just gone past the 2 million unit mark. We were wondering when we were going to go past the 2 million unit mark. It turns out the end of October. So there are 2 million Raspberry Pis in the field.
Now this is a secret. You're the first people to actually know that.
So there are 2 million Raspberry Pis in the field, and if we throw all of our energy into improving the hardware, then we run the risk of kind of orphaning all of those people. So wherever we can, we've been trying to do software improvements. And I think there is still if you go and boot up a year-old operating system image or an 18-month-old operating system image on a Pi, you'll get an idea of how far we've come in terms of stability and performance. I think there is still a lot of work to do on the software side, but it is getting to the point now where we are thinking a little bit about hardware. I think we've always said we've done 2 revs of the hardware. We did the Rev 1 and Rev 2. We did the double RAM Rev 2. So I think we've always said we're going to do 1 more rev. We want to get that Class B CE mark. We want to get the consumerized CE mark because we're currently a Class A product. We want to get the power consumption down a little bit. Right now, the power supply setup that we have on the Pi was kind of driven by our lack of volume at the start. It's very hard to get good power supply components at low volume at a decent price, so we have a very simple linear power supply that chucks away about half a watt of power. You see the 3v3 reg on the board, as Dave knows. Yes. The 3v3 reg on the board is big and fat. We soldered down onto a big slab of copper because it does throw away hundreds of milliwatts of power. So we've got some work going on to improve our EMC performance, get the power consumption down. We may play with the form factor a little tiny bit.
Sorry, case makers.
Yeah, case makers should probably prepare for us to do the obvious thing. I think if you look at the Pi form factor, there's one obvious thing that's a little bit wonky with it, and I think we've always said we're going to try and improve that. So the little things. Eventually, there's going to be Pi 2, and there's obviously, we're not going to be shipping Pi 1 in 20. We will be shipping Pi 1 in 2020. But we need to not just be shipping Pi 1 in 2020. We're going to need something new at some point. But I think that kind of Pi 2 thing is some distance out. So I don't think you should expect a Pi 2 from us in the next couple of years. But like we said, we think we can go a long way with the software, on the software side.
Great, thanks. We've got a question from the audience here.
Someone hold us something, please.
Send to my friends on the internet.
Oh, at the back.
Hey, I heard you say before, like, one of the original sort of inspiration was that applicants to Cambridge didn't have as much knowledge of computing as you saw in previous years. So obviously the Raspberry Pi has exploded into something much bigger than that. But have you seen that change take effect? Do you know if that's happened?
I don't know if it's actually to do with the fact that people are being educated better at school yet. I think it's very, very early days and we're not going to be able to tell. But we have seen applications at Cambridge go up about 300%, which is probably because we go out and say, hey, if you want to come to Cambridge, there aren't very many people applying to do computer science. So we have seen an effect. I'm not exactly sure what's causing it. It's something to do with Raspberry Pi, but I don't think it's yet that people are doing more learning in schools.
And of course it helps that there are a lot of other people trying to solve the same problem, right?
Yeah.
So when we started doing this in 2006, we were the only people really talking about it. And I think since then, the Casses of this world and Eric Schmidt standing up and going on about it in Edinburgh and all of that stuff has really helped. So there are a lot of young reward statements. So there are a lot of organisations trying to solve this problem now. And I think all of those, they create visibility as much as anything else. They just create visibility of the fact that computing is fun and computing can be a great career and that it is an option for you at university. Because one of the big problems we have is because very few schools teach computing, it's a real leap of faith, I think, for somebody to decide they want to go to university and do a subject. It's not often a massive leap of faith to go to university and study physics, because you probably know physics at school, so you have some idea of what it is. For a lot of people who choose to do any, not just computing, but any engineering subject, there's a leap of faith involved, and kind of getting rid of that leap of faith is a really important part of getting numbers up.
The perception has changed publicly, I think, because of ourselves and other bodies, but also the media, and now people starting to understand what computing is. And it used to be at Parents' Evening, you would get everybody coming up saying what's the difference between ICT and computing, and actually what you'll get people coming up now is saying the last few years I've noticed, I want to do computing because it's cool and interesting and fun. So things have definitely changed.
Right, I'll go on, Alan.
One of the things I'm trying to do at the moment is to make sure that Raspberry jams are more accessible and that the quality is improved on those. So I'm writing a jamual to kind of help people. okay, the Raspberry jam.
Sorry.
The Jamifesto as well.
The what?
The Jamifesto.
Oh, right.
That's actually
So, well, if you were to go to the ideal Raspberry Jam event, what kind of things would you?
It would be exactly like this, right?
Now,
Beams.
for the viewers at home who can't see, they can only see you, and they think that the perfect Raspberry Jam event would have you at it.
Yes.
But what other things? So if you imagine nobody here has seen what's downstairs and happening around, what kind of things would you say to people you'd like to see at a Raspberry Jam event?
I want to see more kids and parents getting involved and coming along, and it's a great space here, but I want to see big spaces full of, you go to some of the maker fairs and stuff, and just once you get to a certain size, it catalyses and there's just a buzz. This is a fantastic space, but
it's a good way for kids and parents to learn together as well, which we like to see, and there's been a lot of that going on downstairs today. And Raspberry Jams, as you know, can take a lot of different forms. I've been to some which are a bit like university lectures, where everybody's sort of sitting in a theatre and listening to stuff at the front. I've been to some which are just demos. You'll have a bunch of tables around the edge of a room, and there are a lot of people showing off what they're doing with their pies. And then you get stuff like this, where you've got talks downstairs. There are lots and lots of sessions running with kids learning stuff, and people have robots downstairs. There's a thing which looks a little bit like a Stargate. I'm not quite sure what it is. And
A working Stargate.
Yeah.
Chevron 5 lot.
so what I think what Liz is saying is this but bigger, and it's the involvement and the engagement and the family thing going on. I think.
And lots of mums and dads.
It's the mix of people. So when I was a kid, I used to go. We had a computer club, so I didn't have. There were teachers at school who were interested in computers, but I got most of my computing education from my computer club that I used to go to every other Friday night at the local college. And the cool thing there was you had a mix of people. You had young people who wanted to learn about computers. You had older people who wanted to learn about computers. You had people who worked in the computer industry. And it's that mix of people. I think if you don't have that whole range of ages and that whole range of abilities, then it kind of sucks, because there's no one. The people, either the people who want to learn don't have anyone to learn from, or the people who've got something to teach don't have anyone to teach. So
If I could just tag on to the end of that, some people who are not fans of jams might say that at a Raspberry Jam event, you're just going to get the people who would be interested in this anyway. So what can we do to appeal to the wider fringes of society and then get them to come along?
free pizza. that was a good start. I think it goes back to something that Clive was saying in his talk, that the formal education, we talk a lot about informal education, and certainly at the start when I was Reply, I had a real feel of going around the outside of the education system, of just going and appealing directly to kids and kind of going through non-traditional channels to reach children. I think that we've always said the problem with that is that you do tend to only get the people who are interested. You only get the people who would have been interested anyway. And so the formal learning, the engagement with one of the reasons we're doing much more engagement with schools is that schools are where the mass market is. Schools are where everyone is. And if you can make it work in schools, then you can make it work. Then you can make it work for the people who didn't know they were interested, and only find out whether they're interested when they've sat in front of it for half an hour.
We've seen some jams which are being organised by kids as well. So Machynlleth in Wales, there are some schoolboys there who are running the jam, and so you get quite a different demographic of that because they're publicising it at school, and but they're all very different, and I think that they all have something very valuable to them. You can't. One thing I don't want to see is jams all stamped out and looking the same. It's, each one is different, and I think that's very precious.
Yeah, it's good character, isn't it?
Yeah.
I mean, this isn't really a normal jam. This is kind of a. I mean, I would have liked to
It's
show.
a super jam.
Yeah, I would have liked to show you a real jam, but the fact that you're here made it not.
We should find some way for you to organise jams closer to where I live.
Well, we do sometimes do I mean, we do sometimes go to jams without actually saying we're coming, so then people don't know, and then it's normal. Cheers.
You have a question. What's your experience at the lower age range? My daughter's 5, for example. She loves to jump and jerky and play with that, but she hasn't quite got beyond that. And I'm wondering what, are people using it in schools down to the age of 7, or is that still to come?
Probably not at the moment, simply because, again, when you go into primary schools, it's non-specialists. And so what we've come along with is this fantastic thing, but actually it's quite a bizarre little thing. It's, people will say, well, what is it? It's a computer. What do I plug into? Well, a monitor. Yeah, but then what do you do? Well, it's a computer. So there is this activation energy to using it, which our job is to bring that down, and that's what we're doing, and that's what we'll continue to do until it becomes completely normal. And so at the moment, after 15 years hiatus, it's suddenly bam. There's this thing called computing. It's like suddenly saying in maths, we've got a thing called calculus. It's really cool and useful, but it's quite hard. Would you like to have a go? And everyone's like, what? And so there is this activation energy to get over. And I think that's coming down, and when it becomes normal for people to say, I've got this cool thing, let's hook it up, let's do some interesting things. In school, because of course, teachers are time poor and resource poor, and they might not have the support. In a primary school, they might not have a technician, for example, who can help set these things up. So these are things that we're really conscious of, and I don't think at the moment, at the age of 5, 6, 7, it might be scratch on laptops, but not physical computing and using things like Pi as a tool for exploring and creativity. But that will happen.
Yeah, I mean, one of the things that we're working on at the moment, we're actually we've just hired a couple of people to help us work on this, is educational materials for primary level, and it's not just for the kids, it's for the teachers as well. Because these aren't necessarily people who've had exposure to computing before. So it's schemes of work, lesson plans, so that they can be led through how to set the thing up, how to work with the kids, at the same time as the kids are doing it.
I think there's definitely demand from schools, because we ran a little outreach program and involved 4 schools and gave 50 kids a pie each and stuff. And then we start getting requests from other schools, the word goes around and everybody wants to get involved. I mean, I think if there was one thing that would be really useful, if there was any way to set up a kind of roadshow to turn up at a school with 20 pies and all the gear and a few breadboards and LEDs and stuff, just to show people what the potential is, because when they do see that it really sets people's minds going.
So one thing we did over the summer, the new curriculum, the 2014 curriculum, has all this wonderful language in it. It was largely written by Simon Peyton-Jones at Microsoft Research, and he managed to get in there all of this amazing language about children by the age of 8 will know how to program in 3 different languages, and will know how to reason about the time complexity of various algorithms. They all have to be functional. One of them has to be
a 5-year-old
one of them has to be Haskell. So you wrote this wonderful curriculum, but of course, like all curriculum documents, it's incredibly condensed. So one thing we did over the summer, we subsidised an effort by Miles Berry and a couple of other people to take the curriculum and do that first level of unpacking, particularly for primary schools, to unpack that into, so what does this actually mean? That it's not course material, it's not lesson plans, but it's that intermediate, trying to unpack from this idea of something directly into lesson plans is very hard. So it's the first stage of unpacking to kind of a map of what a set of lesson plans might look like, and that's been sent out to, so we and ARM co-sponsored that. And that's been sent out to every primary school, I think.
Yes,
we printed physical copies and sent it to every primary school in the country. So hopefully primary schools do at least have that first round.
It has been a bit of oops. Sorry.
I was just going to say, we don't want there to be an excuse to say, well, we'd love to get involved, but don't know where to start. This is...
Yeah, and it has been a bit of a learning curve for us, because originally we thought that what we were doing was making a piece of hardware. We were going to make a little computer. Now it turns out that what we're having to do is help with this change in the curriculum. We're having to write lesson plans, we're having to find out different ways into schools, and it's enormously good fun. It's quite challenging. We're having to grow our team, because right now I think there are 6 of us in the office.
Yeah, this isn't 2.
This is us, yeah.
This is about half the team.
And So yeah, it's a challenge, and we're working on it. It's kind of fun.
Okay, the next question from the internet is regarding your original aims. At what point would you consider Raspberry Pi a success?
So I think we always used to say that 1,000 engineers a year, 1,000 additional engineers a year in the United Kingdom would be a good success story. I think that's still true. I think 1,000 additional engineers a year would be transformational for industry. I think that few people could make a big difference in a country the size of the UK. I think we've got greedy. Yeah, I think we'd like to replicate that. Obviously, it'd be nice to have 2x that, 4x that. I think at the very minimum, we'd like to replicate that at scale in the rest of the developed world. Would be good. So yeah, I think when we know that, we'll know that in. One of the problems with this is it's a pipeline. So the problem was a pipeline. We stopped creating new 8-year-old computer programmers in 1992. And we didn't notice for a decade because that pipeline drains out and everything's fine. So it's a pipeline that we have to fill back up again. And you can get, I mean, we're doing great work with 16-year-olds, and the great thing about 16-year-olds is they get to the end of the pipeline in 2 years, not 10 years. But it's going to be a decade before we know. And there were some early signs. I mean, the uptick in Cambridge computer science applicants is a good first sign, but it's kind of a second order effect as opposed to effect. Yes, 10 years. There are other measures, of course, and mine is that I will never ever have anybody come up to me and say, I've got a Raspberry Pi, what do I do with it? That is something quite seriously. Because that will mean they understand computing, they've got an idea of what this little thing does, or what computers in general do, and how to code, and how to create, and how to do cool stuff. And that, at the moment, is quite rare.
You obviously see successes on a personal level, you know, like meeting somebody like Amy and seeing that it has done wonders for her individually. That alone is worth an awful lot.
Yeah, we know people who have. Liam Fraser, who you might know because he was running our download server for us. He was just finishing school when he started with us just as a volunteer. He actually took a year out, completely changed what he was going to do. He reapplied to university. He's now doing computer science at York. He spent a year working with Mythic Beasts, who are hosts, internet hosts. And he's all of a sudden got this fabulous CV because he picked up a Raspberry Pi 2 years ago. And it's really nice to see.
Definitely. Same with Ryan.
Yeah. Hey Ryan, where are you?
I think he's watching. Oh no, he was watching downstairs. Another question from the floor, if I have one. Okay.
How important do you think the physical computing side is for inspiring kids to get into computing?
Physical computing is crucial.
Yeah.
So for me as a software engineer, massively and surprisingly important. That gentleman there put more GPIO on the board than I possibly would have done had it been left to me.
Maybe.
I'm Pete. And should be up here, but he's hiding at the back. Yeah, I'm a software engineer, and I think the things I thought people were going to do with the Pi were move pixels around the screen, which is what I did with my BBC. That's much less sexy than it was 25 years ago. But making objects move around the real world is just as sexy, possibly more, because you can connect those things to the internet now. So I think it's massively important. And some of I guess we should have known this was going to be popular because we could see what people were doing with Arduino, which is, what kids were doing with Arduino. The number you go to a Maker Faire, and the number of kids you see 2 or 3 years ago doing really 70-year-old kids doing really impressive stuff with Arduino. I think it should have, in hindsight, been obvious that people were going to do a lot of that with the Pi.
But there is something much more compelling about making an LED that you've sold to a bit of breadboard go on and off using a button on your keyboard than there is about making a pixel flash on and off using a button on your keyboard.
I was about to say exactly the same thing. I mean, when I got my first home computer in 1980 or something, I spent more time kind of mapping out the circuit diagram and then making add-on boards than I did actually writing software for it. My background's electronics, and for me that's much more interesting than the software side. But how close were you to not having the GPIO on there at all?
I possibly overstate it, but Pete's certainly not been for more GPIO than I think you'd have had a couple of GPIOs or something up to me. So.
It's getting closer, I don't
know.
I think there's virtually zero chance that Pete would have allowed the board to go with no GPIO on it.
There was equally no chance you would have let the board go out without an internet connection.
Yeah, absolutely.
Yeah.
So it's all fair. But
yeah, Pete didn't want an internet connection.
But
Should we
we
get
couldn't
P2C?
afford it, it was too expensive, come on. But we found a way.
Literally tens of cents of magnetics in that magnet.
Yeah, well, more than tens of cents. It was quids, you know, it was serious. But no, what's interesting is if you look at all the projects with Pi, over 50% involve interfacing something to it, whether it's a simple LED or whether it's something immensely more complicated. But I think the important thing is that what we all forget is intrinsically embedded computing is far more pervasive than ordinary on-the-desk computing. And that's the skill base that we really have to bring forward in the community, that you understand not only what a computer is, but how it's a tool to do something like control your fridge, and control your fridge and make it more cost-effective to run it. And you know, there's all sorts of things, and the Internet of Things is a massive opportunity for that connectivity of real-world things. Yeah. And trying to make a broad curricular join-up of electronics, programming, Pi, physics, chemistry, biochemistry, all of that is connected.
Art.
Yeah. And trying to make...
Music.
Art, sorry, yeah, absolutely. And trying to join all those things up and make it a tool for all those endeavours is fantastic.
I'm certainly both having the GPIO and the network on there, because you know, if you do that with an Arduino, you get an extra board and lots of money. The Pi's got both of those already. Granted, for my application, the internet's not that important. You don't have internet 40k, but lots of other applications, you know, LEDs on the internet basically.
Amy.
You know, like how you were talking about Arduino, like Arduino have lots of different ways that you can use it. Like they have e-tactiles kind of incorporated. Do you think you'll ever incorporate anything kind of e-tactiles as like maybe a way to kind of encourage more girls? Possibly?
Actually, Rachel, our artist in residence, is off to a Wearable conference in Munich, I think, in January. Yeah, we are looking at stuff. She's actually working on a project at the moment that involves wearables. With the girls thing, I mean, a lot of people do say to us, I think, that wearables is a really, really good way of getting girls into it. And I do agree for some girls, and other girls are completely turned off by it, but it's something we'd like to see some more of. In fact, there was a girl in Charlotte in North Carolina who's been doing some fantastic wearables stuff. She's got indicator lights on her backpack, so people know when she's turning corners in school and things. That's really fun. But, we've also been working with the guys at Adafruit to find new materials to use with the Pi for wearables. It's yeah, you'll see some new stuff soon, I think.
Another question. So somebody asked, what is your response to people who say that BeagleBone is better?
I can answer this one. The BeagleBone's different. They're different platforms, they're good at different things. We have a slightly slower CPU for some things, we have somewhat more multimedia. They're just different platforms. One thing that's really nice is before the Pi came along, there was nothing under $100. Well, there's the BeagleBone 1 was $90. It's actually quite gratifying to see. I think at the time I gave a very ill-considered interview in which I said that I couldn't understand why the Beagle products were so expensive and that somebody in that supply chain had to be making a pile of money. And I think that the Beagle guys thought I was talking about them, but I wasn't. I was talking about one of their upstream suppliers must be trouncing a big pile of cash in order to get the price up to that level. So it was kind of cool for me to see BeagleBone Black come along at a lower price point, because I think it showed I was right. And it's a nice board. I mean, I personally would buy a Pi, obviously, but you know, it's just nice to see that somebody else has managed to get south of $50.
Yeah, so my answer to that, to anyone who sort of suggested that to me, would be that the BeagleBone is, for some people, they go, well, I tried the Pi for this and it wasn't quite good enough because of, some such a tiny bit on the spec that people probably decided to switch out for something else that they thought was more important. And for them, if it's filling a gap for them that they physically can't do the thing they're trying to do with a Pi, by all means you can use a BeagleBone. But the BeagleBone isn't a charity foundation set up for education. We as Raspberry Pi users are trying to put out this educational message, and we're trying to change the world in that respect. So if it's just a competing board, then it's a completely different caliber.
It'll be slightly more competitive. I would advise anyone to try them both side by side before concluding that the BeagleBone is a better board.
Can I just add a quick point to that? I was at university the other day, and they were actually using Pi and Beagle, or Beagle Bones together, networked together, because one was good at one thing and one was good at another thing. So they're not necessarily competitive, they are different.
It's kind of a status thing as well, like it's cool to like the thing that, to dislike the thing that's cool, so Raspberry Pi hipsters, Another question from the floor?
Given your charitable aims, have you come across any commercial applications that have surprised or amused you?
Any commercial applications? I think that the media centre thing has been a big surprise. So there are some hundreds of thousands of people using the Pi as a media centre. It's the XBMC performance on there is really good now. And so I don't think we'd imagine that this early in the project we'd have a genuine consumer market for the Pi. Something like 20% of the market is XBMC.
Yeah, so apart from the PC, we are now the biggest platform for XBMC, which really surprised us.
Yeah, we're the largest non-PC platform by a long way. So we're previously jailbroken Apple TV2s were the premier platform for XBMC, but now we are. So that's been a surprise. I think the number of people who've been using them as industrial control devices, there are people integrating into industrial products, is interesting.
I think the test apparatus in the factory that makes Raspberry Pi runs on a Raspberry Pi.
Yeah. I've seen an 18 test lab machine in Broadcom in Australia. Someone sent me photos of an 18 machine, automatic test equipment machine that uses a Pi inside Broadcom. So they get everywhere, even inside Broadcom. Yeah, cool. So that's probably all I have to say. Can we do a couple more? Would that be all right?
It's just another commercial application. I know a guy doing software-defined radios, and Raspberry Pi is to do tracking, software tracking within supercomputers.
Yeah. SDR, I think SDR is going to be a really big thing for us. We've just, there's a guy called Andrew Holm at Broadcom in Cambridge who builds, we put his stuff on the blog a while ago, he builds GPS, homebrew GPS, so you can build a purely a good GPS receiver with no custom silicon in it. And he uses the Pi as the downstream end of that. He's been working on a GPU accelerated FFT library, which is enormously fast. And so we think that once that gets into the wild in a few months' time, there'll be a lot of cool SDR applications that people can do with the Pi. We've got to see that.
And there's some sort of left field stuff as well. There's a theatre in Edinburgh that uses Pis for their ticketing, and they also use the same Pis to stream what they're doing in the theatre out into the lobby, so you can come in and you can watch what's on stage without having to buy a ticket, and it's all done by Pis.
Cool. Can I have the last word? I've come here and inflicted this on you all. This is a charity moustache. I do encourage anyone in the room who wishes to dispose of a little bit of money to go and find my Movember MoSpace page and donate to my moustache. It's really for Liz, because she's the one who's going to put up with it.